Borland. In the 1990s, this name was known to everyone, even to those who never used Pascal. For nearly 20 years, Turbo Pascal was taught in schools and universities, and for at least 15 years, another of their products, Delphi, was one of the most famous and popular development environments. And by the way, it's still alive today. So how did it happen that a company which created two, one might say, revolutionary products disappeared almost without a trace? I'll tell one version of this story. It's a story about the role of a leader's personality in the fate of a company.
In the late 1980s, many people launched Turbo Pascal on IBM PC computers for the first time, and for quite a few of them, it looked almost like a miracle. Because back then, the normal way looked like this. You start a text editor and write or edit the program source code, save it, exit the editor. 2. You run the translator, what we now call a compiler, passing the source file as an argument. If there are no errors, you get an object module, machine code for your algorithms, but without fixed memory addresses. 3. You run the linker, giving it the object module files. It links them into an executable program, assigning memory addresses to every variable and subroutine and patching all references accordingly. Now the program can be executed. 4. You run the program and see how it works. If it doesn't work correctly, well, obviously you fix it, which means repeating the entire circus from the beginning. And more often than not, you already run into trouble at step 2, when the compiler finds errors in your source and writes something like, in line X you have some nonsense, and in line Y you're missing a semicolon. Now you have to reopen the editor, find that line, and fix it. With Turbo Pascal, you worked inside a text editor, and without leaving it, you could press a single key to compile and run the program. When the program finished, you were instantly back in the editor. If something was wrong in your code, you weren't just told about it. You weren't forced to hunt for the faulty line. You were automatically taken straight to the line with the error. All you had to do was fix it. In short, if compiling a program used to take a week, now it could be done in 2 hours. Later, many other amazing things revealed themselves. You could execute the program line by line, inspect variable values on the fly, even change them during execution, and much, much more. But that first feeling, that someone had put a tool in my hands and I suddenly felt all-powerful, stayed with me for life. Against the backdrop of traditional compilers, Turbo Pascal looked like a Vickers machine gun among muzzle-loading muskets, and it was immediately clear why it was called Turbo. It was also obvious why it became so popular among beginner programmers, teachers, and students. For its speed and convenience, one could forgive it a lot. Even if it had been a toy compiler capable of building only small educational programs, it would still have been popular. And if it could produce fairly large programs of decent quality, then surely its creators were destined to get rich. So, let's meet the people who actually did this.
The company began in 1981 when Niels Jensen, Ole Henriksen, and Mogens Glad founded a firm called MIT, Market in Time. They didn't yet know exactly what they would be doing. They simply believed in personal computers, in themselves, and in their luck. At first, they wrote software for small machines running CP/M. In 1982, they attended the CP/M 82 exhibition in San Francisco. There, they concluded that if they wanted to sell software in the U.S., they needed an American company located in the U.S., not one based in Ireland. And that's where they met Philippe Kahn. At the time, Kahn had a rebellious streak. He rode a motorcycle, played the saxophone, had a degree in mathematics and a conservatory education, lived illegally in the U.S. without a green card, but he had a very clear idea of what he wanted to do to make money. So the three Danes brought him into the company, and they renamed it. According to legend, it was Kahn who proposed the name Borland, supposedly meaning wooded land in a Celtic language. Kahn was always known for unconventional decisions bordering on outright hooliganism. On the one hand, this made cooperation with other owners difficult. On the other, it often guaranteed success. One article about him, by then already the wealthy and famous head of Borland, was titled Kahn the Barbarian. The ownership shares in Borland were distributed as follows: Niels Jensen, 250,000 shares, Ole Henriksen, 160,000, Mogens Glad, 100,000, Philippe Kahn, 80,000. Formerly, Kahn was the junior partner, yet he became president and CEO of Borland, a position he would hold for 12 years until 1995.
Kahn's core idea was simple: to create a convenient development environment, and also a fast compiler, one that wouldn't force you to go out for a smoke while it chewed through your code. In principle, this idea wasn't new. It was in the air. BASIC, which already existed at the time, could be seen as an embodiment of it. But Kahn actually made it work, and made it work so well that his solution became a model for many future tools. In 1982, Kahn started pushing this direction and found a talented programmer who shared the same vision. Most importantly, this programmer had already created a Pascal compiler for CP.M. They began developing Pascal for MS-DOS, not just a compiler, but a full development environment. And in 1983, the first version was released. That programmer was Anders Heilsberg, the author of Blue Label Pascal. The name Turbo Pascal perfectly captured the essence of the product. The compiler was incredibly fast. Where normal compilers took anywhere from 5 minutes to half an hour, Turbo Pascal compiled programs in under 5 seconds. Borland always had a knack for naming. The product was initially intended for educational institutions, sold at a low price, $49.99. Professional compilers at the time typically cost around $300. The initial market estimate was about 30,000 potential buyers. Even if all of them bought it, that would mean about $1.5 million in revenue, and of course, not everyone was expected to buy. In reality, Borland sold 3,000 copies in the first month, $150,000 in revenue. Local banks even began refusing to process checks and credit cards, suspecting fraud. 2 years later, in 1985, Byte magazine reported a staggering figure for a programming language: 250,000 copies sold. That was 8 times the original optimistic estimate. That meant $12.5 million in revenue, an overwhelming success. 6 months later, sales reached 400,000 copies, $20 million. Over the following years, Borland aggressively developed development tools. Several languages appeared with a familiar environment: Turbo Basic, Turbo Assembler, Modula 2, Turbo Prolog, Turbo C, later Borland C. An active rivalry with Microsoft unfolded and continued into the mid-1990s. Between 1990 and 1992, object-oriented programming was added to Pascal, followed by Turbo Vision, an object-oriented library for creating modern, for that time, applications with windows, menus, context-sensitive help, and more. Turbo Vision offered a clean and elegant concept for window management, UI elements, input validation, and component interaction. As a result, application development became much faster and easier. Turbo Vision itself also served as an excellent educational example of what OOP is, why it's useful, and how to apply it. Many programmers learned OOP through Turbo Vision. Some even tried to turn it into a graphical toolkit. The largest software company in my city continued using Turbo Vision until the early 2000s, long after Windows was everywhere. Turbo Pascal 6.0 itself was built using Turbo Vision, a typical Borland approach: use your own tools. This made products genuinely convenient and high quality because developers experienced firsthand what worked and what needed improvement, and had the tools to fix it. That's probably why Borland products were known for both quality and usability. At the same time, Borland developed products in completely different areas: Eureka, a package for solving differential equations; Sidekick, an Office-like utility suite with a text editor, calendar, calculator, address book, and dialer; Quattro Pro, a spreadsheet application. It looked like Borland's leadership, having made serious money with Turbo Pascal, wanted to reinvest and expand in every promising direction. The problem was that they couldn't choose which direction, so they tried to pursue all of them at once. They competed with Microsoft in development tools, quite successfully in fact, until the late 1990s. They also entered the database market, where good development tools were scarce. Borland acquired ANSYS software and its DBMS Paradox. Later, the Paradox engine appeared, allowing C and Pascal programs to work with Paradox tables. In 1991, Borland acquired Ashton Tate, the maker of the famous DBase. That created a dilemma: either unify DBase and Paradox or let them compete internally and drain resources. Ashton Tate also owned InterBase, a full-fledged client-server DBMS comparable to Oracle, DB2, and the then-new MS SQL Server. Unlike DBase and Paradox, InterBase worked entirely through SQL queries, a completely different programming model. Kahn tried to unite the language and database divisions, the Turbo and DBase teams, but failed. The teams were too different, too large, and the scope too complex. This led to financial difficulties and layoffs in the early 1990s. Microsoft entered the database battle by acquiring Fox software and developing Fox Pro, while also pushing MS SQL Server and MS Access. Competition in this area became fierce. Another front opened in Office software. Microsoft promoted MS Office. Borland partnered with WordPress and launched Borland Office, including WordPress and Quattro Pro. It still amazes me that Borland, despite its vastly smaller size, not only competed with Microsoft, but sometimes even outperformed it.
Around 1993, MS Windows 3.1 arrived, rapidly gaining popularity and instantly making Turbo Pascal and other DOS-based tools obsolete. Now you had to program for Windows, not just because of Windows and graphics like on a Macintosh, but because of multitasking, memory management, inter-application communication, and much more. A new development environment was needed, one that allowed reasonably fast Windows development. Microsoft's canonical approach required up to 3,000 lines of code for a single window and about a month of work. Meanwhile, a DOS Pascal program with Turbo Vision and a couple of windows could be written in a day, but only for DOS. Borland tried to address this with Object Vision in 1992, a Windows RAD tool where you could assemble a window with a mouse in half an hour. But it was slow, limited, and expensive at $495. Even after dropping the price to $250, it failed. Pascal programmers were confused and scattered. Some switched to C to learn Windows programming. Others adopted the newly released Visual Basic. Some left programming altogether. In database development tools, MS Fox Pro became dominant, first under DOS, then as Visual Fox Pro for Windows, starting in January 1993.
In 1993, Anders Heilsberg's team began developing a new language, an IDE. In 1995, it was released. Borland launched Delphi 1.0, priced at just $49.95. At first, people didn't quite understand what it was. It was, first of all, a Windows development environment. Forms were created effortlessly. You added a form, dragged controls from a palette, configured their properties in an inspector, and the UI was ready in minutes. This approach was called RAD, Rapid Application Development. Microsoft had RAD 2 in Visual Basic and Visual Fox Pro, but their components had to be written in C using COM. In Delphi, components were written in Pascal, the same language as the application, and even beginners could extend them. Hundreds, later thousands of Delphi components were created. Delphi offered a full-featured, high-level language. You could do almost anything, unlike the rigid limitations of DBase or Fox Pro. It also had a universal database access mechanism. With a driver, you could connect to almost any DBMS. The application itself barely depended on the database used. Combined with universal SQL support, this was a massive leap forward. Delphi solved several long-standing problems at once: fast Windows development, rapid visual UI design, RAD, database access of virtually any kind. Even the name Delphi hinted at the Oracle of Delphi and the Oracle DBMS, as if saying, "We've built a whole city for your Oracle." Delphi was modest in its requirements. It could run on a 386 at 40 MHz with 4 MB RAM. Slowly, but it ran. With 8 MB, it was fine, and with 12 MB, it flew. Visual Fox Pro officially required 4 MB, but in practice needed 32 MB, which was enormous at the time. For the second time, Borland had created a breakthrough product while competing with Microsoft. What came next? Unexpectedly, in 1995, Philippe Kahn resigned as CEO after disagreements with the board about Borland's future direction. In late 1996, he left the company entirely. In 1996, Anders Heilsberg also left Borland for Microsoft. There, he would lead the development of C# and Visual Studio. Has an employer ever paid you $3 million just to hire you? Delphi 2.0 appeared in 1996 in 3 editions. The cheapest cost $500, the most expensive $2,000. This effectively blocked Delphi mass adoption. Visual Basic was available nearly for free with MS Office, so most applications were written in it. It seems Kahn's low-price strategy had worked better. Borland soon announced that development tools were no longer its strategic focus. Instead, it bet on application lifecycle management tools, none of which became truly popular or long-lived. Delphi continued to evolve incrementally. Improvements appeared, but old flaws remained. It felt like the team lacked resources, and the shortage grew more noticeable over time. Some innovations emerged: Midas for 3-tier architectures, OLE Enterprise for COM, DCOM, and then vanished.
In 2003, Kylix appeared, a development environment for Linux. And a year or two later, it was gone. Developers continued using it for several more years, but no new versions were released. At some point, InterBase was made open source. Soon after, a fork called Firebird emerged, along with a team to maintain it. Firebird is still alive today and remains freely available. Borland, however, later reverted InterBase back to a commercial product, one that lagged far behind the free clone, both in functionality and in the number of unresolved bugs. Around the same time, another interesting product briefly surfaced: Bold for Delphi. Its key idea was that an application was built from a UML model. The same model was then used to generate the database schema and the logic for working with data: creating, reading, updating, and deleting objects, CRUD. In a sense, this was one of the earliest ORM systems. In practice, however, it proved rather weak. It was slow, and its query generation was overly simplistic and therefore inefficient. Later, this line of development continued on the .NET platform under the name ECO, Enterprise Core Objects. ECO made it possible to quickly build a simple application working with several tables, automatically generate the database, and automatically create forms for editing objects and navigating relationships. The problem was that the generated database queries were so inefficient that the system was essentially unusable in real-world projects. Like its predecessor, ECO survived for only a couple of years. Meanwhile, Microsoft released a new development platform, .NET. Developers began migrating from Delphi to C# and Visual Studio. At first, this happened slowly, one by one, but between 2005 and 2010, the shift became massive. .NET grew enormously popular. Borland responded by releasing a new version of its development environment with support for .NET.
However, while classic Delphi had been equipped with a rich set of convenient components that made development fast and comfortable, this time Borland simply didn't have the resources to repeat that success. Users were told to rely on the same components used in Visual Studio, the Windows Forms framework. In the next version, even that was removed, and developers were pushed toward VCL.NET instead. Overall, Borland's behavior towards its users now showed no trace of a backward compatibility policy. On the contrary, it looked more like a desperate attempt to shake off a pursuer. In my view, such erratic decisions point to a deep management crisis and an inability to steer the company in a coherent direction. By the late 2000s, the remaining assets of Borland were sold to Embarcadero, which continues to sell Delphi to this day. After leaving Borland, Philippe Kahn went on to found several other companies. One of them was sold to Motorola for $325 million. Later, he moved into the fitness wearable business. It seems he once again correctly anticipated where demand would emerge. And that's the whole story. To me, it's ultimately about this. A company's success depends first and foremost on whether its leader truly understands where they want to go and where they're leading the company.